Hello friends, now we will start the new chapter, logic, in another new frame. The first exercise 1.1. I will explain all the solved example and all theoretical part and all examples from the practice set from the exercise 1.1. Now let us start. Now let us start mathematical logic. Let's study. In this chapter, you will learn statement and its truth value, logical connective and compound statements, truth tables, negation of statement and compound statements, statement pattern, logical equivalence, tautology, contradiction and contingency. Next, quantifiers and quantified statements, duality, and the last, application of logic to switching circuits and switching table. Now let us start. Introduction. Mathematics is a logical subject and tries to be exact. For exactness, it requires proofs which depend upon proper reasoning. Reasoning requires logic. The word logic is derived from the Greek word logos, which means reason. Therefore, logic deals with the method of reasoning. In ancient Greece, the great philosopher and thinker Aristotle started study of logic systematically. In mathematics, logic has been developed by English philosopher and mathematician George Boole. Language is the medium of communication of our thoughts. For communication, we use sentences. In logic, we use the statements, which are special sentences. Now, what is meant by this statement? It's very simple. A statement is a declarative, assertive sentence. It tells us true or false, which is either true or false, but not both simultaneously. Statements are denoted by small letters P, Q, R. Now the truth value of a statement. Each statement is either true or false. If a statement is true, then its truth value is capital T. And if the statement is false, then its truth value is F. Now the illustrations. First, following sentences are statements. First, sun rises in the east. Second, 2 into 5 into 2, that is equals to 11. Every triangle has 3 sides. Yes, it is a statement. Its truth value is a T. Mumbai is the capital of Maharashtra. Yes, it is a statement. Its truth value is a T, capital T. Every equilateral triangle is an equiangular triangle. Yes. A natural number is an integer. Yes, it is a statement. Now the next is following sentences are not statements. First, please give your pen. This is the request. What is your name? That is interrogative. What a beautiful place it is. It is exclamatory. How are you? Again it is interrogative. Do you like to play tennis? Again it is interrogative. Next, open the window. Order. And let us go for tea. This is the suggestion. And sit down. This is the order. These are not the statement, and that's why. Remember this, don't forget. Interrogative, exclamatory, command, order, request, suggestion are not statements. Next, consider the following. First, 3x upon 2 minus 9, that's equals to 0. Is this a statement? Now we will see. For x is equals to 6, if we substitute x is equals to 6, then it is a true, but other than 6, it is not true. If we substitute x is equals to 3, 3 into 6, if we substitute x is equals to 6, then 3 into 6, that is 18, 18 upon 2, 9, 9 minus 9, it is 0. Therefore, for this equation, 3x upon 2 minus 9 is equals to 0. For x is equals to 0, it is true. For other than 6, it is not true. Second, he is a tall. Solution. Here, we cannot determine the truth value. Next, mathematics is an interesting subject. It is black in color, therefore it's a solution. For this third and fourth, the truth values varies from person to person, and therefore it is not the statement. Let us analyze these statements. In all the above sentences, the truth value depends upon the situation. Such sentences are called open sentences. Open sentence is not a statement. Short examples. Question 1. Which of the following sentences are statements in the logic? Write down the truth values of the statements. First is 6 into 4, that is equals to 25. It is a statement which is false. 6 into 4, that is a 24, but there is a 25 and its a truth value is f. Second, x plus 6 is equals to 9. It is an open sentence, hence it is not a statement. What are you doing? It is an interrogative and hence it is not a statement. The quadratic equation x square minus 5x plus 6 is equals to 0 has two real roots. It is a statement which is true, hence its a truth value is capital T. Please sit down. It is a request, hence it is not a statement. The moon revolves around the earth. Solution. It is a statement which is true and hence its a truth value is capital T. Every real number is a complex number. Solution. Again, it is a statement which is true and hence its a truth value is capital T. Next, he is honest. It is not, it is open sentence, hence it is not a statement. The square of a prime number is a prime number. It is a statement which is false. The square of, if we take any prime number, 5 square is a 25. 25 is not a prime and therefore its a truth value is f. Now next we learn the logical connectives, simple and compound statements. The words or the phrases which are used to connect two statements are called logical connectives. We will study the connectives and, or, if, then, if and only if, not, simple and compound statements. A statement which cannot be split further into two or more statements is called a simple statement. If a statement is the combination of two or more simple statements, then it is called a compound statement. 3 is a prime number and 4 is an even number is a compound statement. 3 and 5 are twins prime. It is a simple statement. We describe some connectives. Now let us learn. First, the conjunction. If two statements are combined using the connective and, then it is called as a conjunction. In other words, if PQ are two statements, then P and Q is called as conjunction. It is denoted by P and Q and is read as P conjunction Q or P and Q. The conjunction P and Q is said to be true if and only if both P and Q are true, then it is true, otherwise false. Conjunction. If the two statements are combined using the connective and, then it is called the conjunction. Again, this is repeated, I think. In other words, if P and Q are the two statements and P and Q is called as a conjunction, it is denoted by P and Q. Okay, this is repeated. Now the truth table for conjunction. See this here. P, Q, P and Q. For P we will take double T, double F, and for Q we will take TF, TF, TF. Now first, see this here. P is a T, Q is a T. Both of them are true, therefore it is a true. Next, T, Q is F, T and F. Both of them are not true, therefore it is F. Again here, F and T, both of them are not true, therefore again it is F. Now the last, both of them are F, therefore the final is also F. Therefore, to remember this, if both of them are true, then it is true, otherwise false. Next, disjunction. If two statements are combined by using the logical connective or, then it is called as a disjunction. In other words, if PQ are two statements, then P or Q is called as a disjunction. It is denoted by P or Q and it is read as P or Q or P disjunction Q. Truth table for disjunction. See this here, P. Now see this truth table. Again we will take the values of PR, double T, double F, and Q is a TF, TF. Now see this again, one by one. If both of them here, that is a T, T, T or T is again T. Next is T or F, again T. FT is again T. and F or F, then it is F. Therefore, to remember this, that is, if one of them is true, then it is true. You can remember like this. The दोन्ही true असतील तर true. One of them must be true, then it is a true. If both of them are false, then it is F. You can remember like this also. Now the conditional, that is the implication. If two statements are combined by using the connective if then it is called as a conditional or implication. In other words, if PQ are two statements, then if P then Q is called as a conditional. It is denoted by P implies Q or P implies Q, and it is read as P implies Q or if P then Q. Truth table for conditional statement. Now see this again here. P, Q and P implies Q. And here, if both of them are same, then it is true. Otherwise, what implies? Now see this one by one. T implies T. T implies T, then it is a T. T implies F. What implies? F. Therefore, it is F. F implies T, and therefore it is a true. And the last is F implies F, and that's why it is a true. Therefore, how to remember this? That is if both of them are same, T, then it is T. F, then it is T. Otherwise, what implies? T implies F, therefore it is F. F implies T, therefore it is a T. The conditional statement P implies Q is false only if P is a true and Q is false. Otherwise, it is a true. Here P is called hypothesis and or it is antecedent, and Q is called conclusion or consequence. Note, the following are also conditional statement. P implies Q. The first is P if is sufficient for Q. Second, Q is necessary for P. P implies Q. Q follow from P. P only if Q. Truth table for now biconditional. Now see this again. P, Q, P biconditional Q. If both of them are true, then again it is a true. TF is again F. FT is again F. And FF is again true. Now you can remember like this. If both of them are same, then it is true. And if both of them are different, then it is F. These are different, F. These two are different, and then therefore it is F. Negation of statement. For any given statement P, there is another statement which is defined to be true when P is a false and false when P is a true, is called negation of P and is denoted by negation of P. This is the symbol. The truth table for the negation is very simple. P and negation of P. If P is a true, then its negation is F. If P is F, then its negation is true. Okay. Now the solve examples. The first example, express the following compound statements symbolically without examining the truth values. First, 2 is an even number and 25 is a perfect square. Now we can write here, let P, that is a 2 is an even number, and what about the next Q? 25 is a perfect square. Therefore, the symbolic form is a P and Q. There is and. A school is open or there is a holiday. Now again here, let P, the school is open, and Q, there is a holiday. The symbolic form is P or Q. Third one, Delhi is in India, but Dhaka is not in Sri Lanka. Now see this here, P, Delhi is in India, Dhaka is in Sri Lanka. The symbolic form is P and negation of Q. Here the word but stands for the and. Next is 3 plus 8 is greater than or equal to 12 if and only if 5 into 4 is less than or equal to 25. Now here we P, 3 plus 8 is greater than or equal to 12, and Q is 5 into 4 is less than or equal to 25. The symbolic form is P double implication Q. Third example, if statement PQ are true and RS are the false, determine the truth values of the following. First, negation of P and in bracket Q or negation of R. We have given that the P is true, Q is true, R and S are false. Now see this here, negation of P and in bracket Q or negation of R. Now see this here, P is true, therefore it is written to T, negation of T, and what about the Q? Q is again T. What about the R? R is F. Now the negation of T is F, and here is again T. Negation of F, it is again true. T or T is a T. F and T, that is a F. This is the final answer. Again you can see this, P and Q are true, therefore we substitute. In place of P, that is a T. In place of Q, it is again T. In place of R, it is F. Negation of F is 2. T or T is T. And what about the negation of T is F? F and T is again F. Hence, the truth value is F. Second, P or negation of R and in bracket negation of Q or S. Solution, P and negation of R and negation of Q or S. Again substitute the values, that is a P is replaced by T, and negation of R means what? Negation of F, and in bracket negation of Q means what? Negation of T or S. S is F. Now negation of F is true, T and T, it is again T. What about the next? Negation of T is F. F or F, it is F. Therefore T and F is finally is F. Therefore the truth value is F. Next is, now see this here. See this here. First is negation of in bracket. Now see this once again. Third one, negation of in bracket P implies Q, double implication in bracket R and S. Now see this here. In square bracket, negation of P implies Q, double implication R and S. Now P is true and Q is also true. R and S, both of them are F and F. T implies T, that is true. That is the negation of T. Double implication, F and F, it is F. Okay. Therefore, negation of T is F. F double implication F. Therefore, it is true. Hence, the truth value is finally is T. Next is negation of P implies Q and in bracket R double implication S. Now we'll substitute the values. That is a P and Q, both of them are T implies T, negation of T implies T. And next is a F double implication F. Negation of T is F. F implies T. F double implication F, that is a true. Now F implies T, therefore it is a T. T and T is a T. And hence the truth value is T. Now the next is example number 4. Write the negation of the following. First, price increases. Its a negation is a price does not increase. Next is 0 factorial is not equals to 1. 0 factorial is equals to 1. 5 plus 4 is equals to 9. 5 plus 4 is not equals to 9. These are the negation. Now we'll start the exercise 1.1. The first example. State which of the following are statements justify in case of statement state its truth value. First is 5 plus 4, that is equals to 13. It is a statement which is false. Hence its a truth value is F. Second, x minus 3 is equals to 14. It is an open sentence and hence it is not a statement. Close the door. It is an imperative sentence and hence it is not a statement. And the same thing is repeated here. Okay, I have completed this. Now the next is 0 is a complex number. Solution. It is a statement which is true. Hence, its truth value is P. Please get me breakfast. It is an imperative sentence. Hence, it is not a statement. Next is congruent triangles are similar. It is a statement which is true, and hence its truth value is t. X square is equals to x. It is open sentence, and hence it's a truth value. It is not a statement. Next is a quadratic equation cannot have more than two roots. Therefore, it is a statement which is true, and hence its truth value is t. Ninth, do you like mathematics? It is an interrogative sentence, and hence it is not statement. The sun sets in the west. Again, it is statement which is true. Hence, its truth value is t. All real numbers are whole numbers. It is a statement which is false. Hence, its truth value is f. Can you speak in Marathi? It is an interrogative. Hence, it is not a statement. Next is x square minus 6x minus 7 is equals to 0 when x is equals to 7. It is a statement which is true, and hence its truth value is t. If we substitute x is equals to 7, then it's equals to RHS, that is a 0. Next is the sum of cube roots of unity is 0. It is again a statement which is true, and hence its truth value is t. We have seen in the complex number. Next, it rains heavily. It is an open sentence. Hence, it is not a statement. Cannot determine how it is heavy. Next is question number 2. Write the following compound statements symbolically. The first is Nagpur is in Maharashtra and Chennai is in Tamil Nadu. We can write in symbolical form. Let P denotes the Nagpur is in Maharashtra. Q, Chennai is in Tamil Nadu. Then the symbolic form of the given statement is P and Q. Next, triangle is equilateral or isosceles. Let P, the triangle is equilateral. Q, triangle is isosceles. Then the symbolic form of the given statement is pure Q. Next is the angle is a right angle if and only if it is of measure 90 degree. One by one. P. The angle is a right angle Q. It is a measure of 90 degree. Then the symbolic form of the given statement is P double implication Q, if and only if. Therefore, it is a double implication. Next is a angle is neither acute or obtuse nor obtuse. Angle is neither acute or nor obtuse. Okay, neither nor. Therefore, P angle is acute and Q angle is obtuse. But there is a neither and nor. Therefore, we take here negation of P and negation of Q, the symbolic form of the given statement is negation of P and negation of Q for the neither nor. Next is, if the triangle ABC is a right angle triangle at P, then measure of angle A plus measure of angle C, that's equals to 90 degree. Solution, that is a mu. Triangle is right angle at B. Now see this again. If triangle is a right angle at B, then measure of angle A plus measure of angle C is equals to 90 degree. Solution, let P triangle is a right angle at B. Q measure of angle A plus measure of angle B is equals to 90 degree. See this here. This again I am repeating here. P, the triangle is right angle at B. Q, measure of angle A plus measure of angle C is equals to 90 degree. Then the symbolic form of the given statement is P implied Q, P implication Q. Next is Hima Das wins a gold medal if and only if she runs fast. Now here Hima Das wins gold medal Q, she runs fast. Then the symbolic form of the given statement is P implies Q. Now see this again here. The symbolic form P double implication Q. Next is X is not irrational number, but it is a square of an integer. Solution, let P X is not irrational number, Q it is a square of an integer. Therefore, the symbolic form is, as there is a but, therefore it is a P implies Q. Sorry, it is P and Q. Due to the but, we apply here and. Okay, next. Question number 3. Write the truth values of the following. 4 is odd or 1 is prime. Now 4 is odd. First is 1 is prime. Then the symbolic form of the given statement is P or Q. The truth values of P and Q both are F. Okay. Therefore, F or F is again F. Next, 64 is a perfect square and 46 is prime number. Now first is, let P the 64 is a perfect square, 46 is a prime number. Then the symbolic form of the given statement is P and Q. Therefore, the truth values of P and Q, P is a T and Q is F. The truth values of P and Q are T and F because 64 is a perfect square and 46 is not a prime number, therefore it is F. Therefore, next is the truth values of P and Q is F because T and F is again F. 5 is a prime number and 7 divides 94. The first is 5 is a prime number, Q 7 divides 94. Then the symbolic form of the given statement is P and Q. 5 is a prime number, it is a true. And 7 divides 94, it is F. Therefore, T and F is F. Next is fourth one. It is not true that 5 minus 3i is a real number. Let P 5 minus 3i is a real number. Then the symbolic form of the given statement is negation of P. The truth value, that is the 5 minus 3i is a real number. The truth value of P is, now see this here, that is the truth value of P is F and the negation of P, that is the negation of F, is again T. Next is 3 into 5, 8 is equals to 8 and 3 plus 5 is equals to 15. If 3 into 5 is equals to 8, then 3 plus 5 is equals to 15. This is. Now let P 3 into 5 is equals to 8 and Q 3 plus 5 is equals to 15. Then the symbolic form of the given statement is P implies Q. Then the truth values of both P and Q are, here the truth value of both P and Q are F. F implies F, it is true. Okay, now the next is, milk is white if and only if sky is blue. Let P, the milk is white, Q, sky is blue. Then the symbolic form of the given statement is P double implication Q. Now the truth values of the both statements are 3 and therefore the truth value of P double implication Q is also T. Next is 24 is composite number or 17 is a prime number. Solution. Let P, the 24 is a composite number, 17 is a prime number. Then the symbolic form is P or Q. The truth value of both P and Q are T, and therefore T or T is T. Okay. The next is if the statement pattern PQ are true, statements RS are false statements, then determine the truth values of the following. First, P or Q in bracket Q and R. Solution. Truth values of P and Q are T, and truth values of R and S are F. Therefore, we write here T or in bracket T and F. T and F is F. T or F is again T. Hence, the truth value of the given statement is 2. Now the same question. Next, that is the P implies Q in bracket or R implies S. Again we write here their values. T implies T or F implies F. T implies T is T and F implies F is again T. T or T is 2. Then hence the truth values of the given statement is true. Third one, Q and R or negation of P and S. Substitute the values. Q and R or negation of P and S. Q means T, R means F. T and F is again F. Or negation of T means F. F and F is F. Okay. F or in bracket F and F is F. F or F is F. Hence, the truth value of the given statement is false. The same question. P implies Q and negation of R. Again, substitute the values. T implies T and negation of F. T implies T is T and negation of F is T. T and T is T. Hence, the truth value of the given statement is true. Next is negation of R double implication. P implies negation of Q. Substitute their values. Negation of F double implication T implication negation of T. Now negation of F is again T. T double implication T is a T implies F. T implies F, therefore it is F. And hence the truth value of the given statement is false. Now next is this is the big one. Negation of P and in bracket negation of Q and R bracket complete, or in bracket Q and R or in bracket P and R. Solve first one by one. Substitute the values. Solve this bracket. Negation of T and F or T and F or F T and F. Now one by one, negation of T is F. Negation of T is again F and F, or again here T and F is F, or again F. Again F and F or F. F and F is F, F or F is again F. Hence the truth value of the given statement is false. In square bracket, negation of P and Q and negation of R, or in square bracket, Q implies P in bracket complete implies negation of S or R bracket complete. Now substitute the values and solve one by one. First is negation of T and again negation of F, or again in bracket T implies T implies S, it is F, negation of F or F. Now one by one, negation of T is F and T, this is and, here is and. Negation of F, it is a T, again or, here is or. T implies T, it is a true. Implies, this is implication. Negation of F is a true. T or F is again T, here is a T. Okay, therefore this total bracket is here. F and F is F, or T implies T is a T. F or T is a true. Hence the truth value of the given statement is true. The next question. Again, negation in square bracket, negation of P or and R, or in bracket S implies negation of Q bracket complete double implication P and R. Substitute the values and you will get the answer. It's a simple one. Solve one by one. Negation of T is F, F and F is again F, or F implies negation of T. Negation of T is F. F and F is F. F implies F is T. Therefore, F or T implies F. F or T is T. Negation of T is F. F double implication F is true. And hence the truth value of the given statement is true. Now the question number 5. Write the negations of the following. First, Tirupati is in Andhra Pradesh. Its a negation is a Tirupati is not in Andhra Pradesh. Next is 3 is not a root of the quadratic equation x square plus 3x minus 18 is equals to 0. Therefore, the negation of the given statement 3 is a root of the quadratic equation, that is x square plus 3x minus 18 is equals to 0. Next is third is root 2 is a rational number. It's a solution. Root 2, it's a negation. Root 2 is not a rational number. Fourth one, polygon ABCDE is pentagon. The negation of the given statement, polygon ABCD is not a pentagon. Next is 7 plus 3 is greater than 5. Its negation is 7 plus 3 is not greater than 5. So this is the solution. There is a negation of the given statement. And in this way, I have completed the first exercise 1.1. Now we'll see in the next video. Till then, goodbye.